I took the time to do it, it's because it's not like the other TVM questions that you may have dealt with, which is, classic, right? Solving for the present value, solving for the future value. But in this one, we're actually going to solve for payment, okay? We're going to solve as payment as being our missing variable. So it's important to just know how to solve for that missing variable and kind of know how to use, once again, our timeline and our formula to our advantage, and to kind of bridge two parts together, okay? So as you can see, flowchart, solving for payment, pretty straightforward. So we're going to read this together. We're going to try to make sense of it, and hopefully it works out. So your 6-year-old wants to go to Princeton for med school, okay? So your 6-year-old wants to go to Princeton for med school, and you know that this is going to cost you 120 grand per year for 6 years, right? Going to med school is a long process. It takes some time. So it's going to cost 120 grand every single year for 6 years. So on her next birthday, all right, so if we're talking about her next birthday, so when are we going to start putting money aside? At what time? If on her next birthday, we're going to start putting money into an account. You could say T1, but you could also say when she's going to be 7 years old, okay? I'm going to use a different approach, but Shane, what you said is correct. And we're going to put this money into an account that pays 8% annually, all right? So we know for sure that this is going to be our K. Our K will be 8%. We know that that's going to be an annual rate, okay? And we know that we're going to deposit this amount every year until her 17th birthday. Now, Shane, this actually touches on what you put into the chat. You said T1, and that's totally correct. But the thing is that when we're dealing with these random dates that are kind of set in stone, I actually decided that it's more convenient to actually use the dates that they provide and kind of build our timeline off that. And you'll see exactly what I mean in just a second. We're just going to finish reading the question. Now, the first tuition payment will be payable on her 18th birthday, and then the second on her 19th, and so on and so forth. We want to know, how large are these annual deposits to this account? When we're talking about deposits, I want you to remember that deposits is quite literally payments, okay? Deposits stand for payments. Now, after reading these types of questions, the first step, in my opinion, would be to plug stuff into our timeline. We need to visualize what's going on, and I'm going to give you what's my best practice when visualizing questions of the sort. Then I'm going to ask you if everything's okay. All right, so first step, what we would like to do is, obviously, we're going to begin at 0, right? At T0. But the thing is, our kid is 6 years old, and we know we're going to start investing when they're 7 years old. So what I like to do is I like to do it like this. We skip a few years all the way to T6. We put T7. We put T8, and then we could skip a few more years. The reason why I'm starting at T6 is because that's when the question actually begins. And I don't want to like mess up my numbers, okay? So I rather really just plug in the dates that were provided to the question such that I can really, if I ever need to count for n, I could count them one by one, okay? This is just a trick for you not to like get lost or make mistakes. That's essentially what I'm trying to say, okay? So we could say that starting her 7th birthday, we're going to have a payment. And on her 8th birthday, and on her 16th birthday, and on her 17th birthday, we'll have our last payment. So we have payments occurring all the way through, okay? But what's so special about year 18? Well, year 18 is when the first tuition payments actually begin. So starting year 18, and I guess we'll put this in a different color just to stress the difference, we're going to have 120K that we need to pay every single year for quite some time. 18, 19, 20, 21, 22, and we're going to add another one, 23. All right, so we're going to have these 6 payments of 120K. All right. So as you can see, what we could say here is that we actually have 2 sections to this problem. Okay, and in just a second, I'm gonna ask y'all if everything's okay. But we have 2 sections to this problem. We have the first section where there are tuition payments. And right now, really, we're in step 2, right? We're just trying to define what the heck is going on in this question. So we have our first section, which is tuition payments. Then we have our essentially another section, well, the real first one. That's going to be our annual deposits. Okay. So we have our annual deposits and we have our tuition payments. So we could call this section A, and we could call the other one section B. So let me just ask you all a quick question. So far, are we good? Do we see what I'm doing? I'm just visualizing what was said in the question. Are we okay? Like everybody's following? Yes or no? Yeah? Yeah, so like you see what I'm doing. Okay, cool. So this is pretty interesting. Now, let's try to remember what is the question actually asking us to do, right? The question is asking you, hey, you know that you need to make these 6 payments of 120 grand every single year, okay? And you want to start saving for those payments starting today, okay? Oh, starting T7. And you want to know how much money do you need to save on a month-to-month basis to be able to have the amount of money needed to pay for school, okay? So we can kind of like, go further in that. We can try to visualize this a little bit more, such that the next step makes total sense. So you know that you're going to start paying right here. You know payments begin at T18. So you want to, the 120, the tuition begins at T18, and you want to have enough money by then, okay? Now the question is essentially, how much money do you really need at the beginning of the tuition payments? In other words, how much money, right, do you need to have by T18? You can actually break this down by essentially doing the following, assuming that you would always invest money. So what we would do to find the amount of money needed at T18 is you would find the present value of these tuition payments. And the present value of these tuition payments will be how much money you will have to save for. In other words, make deposits to on a yearly basis. Okay? So what we're going to want to do is we're going to want to find the present value of all of these future payments, of all of these future tuition payments, right? Essentially how much you'll need then, and then we're going to try to find our payment. I feel like I'm not using English well, so I'm going to draw it up, I'm going to write it down, and from there, you'll see what I mean. So there are 2 ways to do this, okay? There are 2 ways, there's actually 3 ways to do this. So to do part B, we're actually going to begin with part B. To do part B, there are 3 ways to do this. 1, by simple discounting each year. 2, with your financial calculator. And then 3, with the flowchart. Now, with the flowchart, what you get to notice is that we're dealing with payments that are lasting for a specific amount of time, right? T18 all the way to T23. And we know that these payments are going to be essentially occurring at the end of the year. And we know that these payments will be the same every single year. So you know that you're going to be dealing with a normal annuity. All right. And in this case, we want to find how much money you would need at this date. In other words, you want to find what is the total present value of these tuition payments to the university. So you could simply use the formula for normal annuity, or you could plug it in within your calculator. Okay. So I'm going to ask y'all, could somebody solve for the present value of the university payments? Somebody tell me what that would be. You could either use you could discount every single one of them one by one, or you could use your financial calculator, or you could use a flowchart by using the normal annuity formula. And in the meantime, I'm going to plug in the formula for the normal annuity. So you'd have payment over K times 1 minus 1 over 1 plus K to the power of N. And that would be your formula. And just to make it super clear, we have our payment, we have our K, and we have our N. In this case, we know that payment is 120K. We know that K, I like that. So K in this case would be 8%. But now, Waleed, it's a good question. What is our N, right? Well, once again, we want to find the present value when you start paying the school. So at T18, so in other words, you would have 6 as being your N, right? Because you're making 6 payments, right? You'd have 6 being your N. And this is a question that makes sense way more when we finish it. But what you want to understand, once again, is that we want to figure out how much money would we need by the time our daughter goes to school. So here we're going to need to find the future value, right? And we're going to want to find the payment in that future value, okay? So the future value that we need is actually the present value of these university payments, of these tuition payments, okay? The present value of these tuition payments will be the future value of our investment, of our deposits, because we want our annual deposits today to be equal to the present value of these university payments we're going to be making onto the future. So I need everybody to tell me, well, at least like 2 more people, to tell me what is our present value of these tuition payments. What is the present value of these tuition payments? Waleed says 55,475.55. I need like 1 more person to give it a shot, please, por favor. I know we're doing a lot. It's like a lot of work. I totally get it, but we're getting there. We're definitely getting there. Now let me just make sure that everything's correct. And you guys put 6 as your N, just to be sure? So I may have to review this question now. I don't know if that's actually accurate. Oh, okay, it's 554,000. That's what I'm saying. I was like, that don't make no sense. I was like, that's a very small amount. Thank you so much. I'm sorry, I read the first one. There you go. That's better. My bad. Hey, listen. I don't know if y'all know, but I'm actually dyslexic. So sometimes reading numbers, when I do it quick. So this is our present value at 18, okay? So this is how much money we need. And I'm gonna say this one more time, and I'm sorry that we've kind of been all over the place, but once again, we're depositing money for our kid starting T7 up until T17. But we don't know how much money we actually need. So in order for us to know how much money we actually need, we need to look at all of those tuition payments that we're going to make. But because we're smart people, we know that we could invest our money. And because of that, we need to find the actual present value of all of those university tuition payments, and we're going to try to get that amount instead. So in this case, we get PV18 is equal to 554,745 and 55. Okay, so that's our PV18. So we know that that's how much money we need at T18 when our kid goes to school, such that we can now move on to part A. Okay, part A is straightforward. Once again, we need to use our flowchart though. We need to think about it. What is part A? What are these payments that we're making in part A? We're making payments, okay, for a specific amount of time, T7 to T17. We know that these payments are happening at the end of the year, and these payments, right, these annual deposits will be the same every single year. So what type of flowchart thingy are we using? I almost gave you the answer. What type of thing exactly? We're using an ordinary annuity. So with our ordinary annuity formula, we're going to solve for payment. Okay, we're going to solve for payment. Now let me ask you this. Are we using the future value or the present value formula? Which one are we looking for? What are we doing here? Which one are we looking for here? We're looking for the amount here. So yes, we're using the future value formula. Okay, so in this case, we know that the future value formula, if my eyes still work, should be something like this. So our future value 18 formula will be equal to, if I'm not mistaken, payment K over 1 minus K. I just want to make sure that I put the right formula down. I don't like remembering. I mean, not really. It would more so be another type of formula. If I'm not mistaken, the formula for our future value of a normal annuity is actually not this one. I'll get it right now. My solutions, I have the wrong one. But give me a second, I'm gonna write the formula down. By the way, if you already have the formula with you, you could just plug it in and kind of get going from there. And you'll tell me what is our payment, what are we missing. So I'm gonna write it down right now in just a second. And I'll actually ask you all to confirm. Actually, no. Oh. Yeah, so the formula for your ordinary annuity is going to be just like this. There you go, my bad. So yeah, this would be your formula that you could use to solve for payment. Now, the only nuance here, we know that we have our K. We know our future value 18 already, right? We have it right here. It's the same thing. Our future value 18 for our normal annuity is the present value of these tuition payments that we have, right? So it's the same thing. But now we need to look for N. What is our N here? What is our N? How many years are we actually, making deposits, right? We're making deposits from year 7 all the way to year 17. So could somebody tell me, what is our N? Shane says it's 10. So if we do a payment at year 7, year 8, year 9, year 10, year 11, year 12, year 13, 14, 15, 16, and then 17, we have 17 payments. We have 11 payments, right? So our payment would not be 10 because our payment begins, once again, right here at T7 all the way to T17. That's how many payments we're making. So we have 11 payments. Do everybody agree that we have 11? Because we have payment at T7 all the way to T17. Okay? So our N would actually be 11. So N equals 11, and we know our K already, which is 8%. Okay? And we already know FV18, just PV18. So I'm going to ask y'all, could you solve for payment? Can anybody take the time to solve for payment? What would payment be in this case? What would payment be in this case? You could also use your financial calculator for this part, I'm not going to lie, because you have all of the values you need, right? But still, the formula is always a good way of going about it. It's the hardest way. That's the way I like to kind of make sure that you know all the nuances. So can somebody solve for payment? What is payment? What is payment? In the meantime, I'm going to give it a shot too. Nice. Everybody, you are correct. Yes. So payment, and I'll write it here in the middle. Payment is equal to this. So this is our payment. Okay. So before, and I think we'll take a little bit of a break just because I need to drink some water to kind of be able to speak with the same enthusiasm. I was kind of less energetic. Maybe that's a good thing in this one. So I'm gonna go grab a little bit of water. But before we do that, are we okay with this question? Was this fine? Like, how do we feel overall? How do we feel? Are we okay? We're good? Okay. Any questions?